This is the tale of three frogs and some challenges they set. Feel free to try these for yourself, either with pen and paper or the aid of a spreadsheet. At the end of each slide, you can pause the video and try these for yourself. Now, Freddie got pretty fed up hopping around, so he wondered what would happen if he hopped distances which are in a geometric progression. Now, Freddie was pretty quick, so he could hop infinitely many distances in no time at all. So this is the journey that he travelled. How far did he cover? Well, a simple calculation shows that the distance he travelled was 1 unit. And so the infinite series as shown is 1. He got quickly fed up with that, so he thought he would try another challenge. What would happen if he multiplied each of the distances he previously covered by the natural numbers? In this case, this was the distance he would travel, which can be written in this form. But again, a simple calculation shows that the distance he travels this time is twice as far as before, 2 units, and so this is the sum of that series. In other words, his new distance is twice his old distance when he multiplies each of his previous jumps by the natural numbers. Now, he was just about to think of a new challenge when along came his friend Fibonacci, who told him about the numbers that he'd invented. Now, these were numbers that started off with 1 and 1, and then he computed all additional numbers by just adding the previous 2. This time he said, why not multiply your original distances by my numbers and see how far you travel? Which can be written in this form. This time, a simple calculation shows that the distance he travels is also 2, as previously found just by multiplying his original distances by the natural numbers. In other words, if he multiplies his original distances, which are in a geometric series, by the natural numbers, or the Fibonacci numbers, he still travels a distance twice his original distance. Fibonacci said, why not try this? Why not multiply the distances you've just travelled also by the natural numbers and see how far you travel? This time he found out he travelled 10 units. So if that's true, we have the new distance travelled being 5 times the distance travelled only with the natural numbers, only with the Fibonacci numbers, and 10 times his original distance. While they were thinking of new challenges to investigate, along came their old friend Fermat, who said, why travel all that distance and be so far away from home when you can hop forwards and backwards? So this time they tried jumping forwards 1 unit and back a half a unit, forward a quarter a unit, back 1/8 of a unit, and see where they ended up. This time a simple calculation shows that they end up 2/3 the distance that they were from the start. Always open to a challenge, Fibonacci and Freddie thought, what about if we multiply each of those distances now by the natural numbers? Where would this get us? Whilst Fibonacci and Freddie started jumping, Fermat decided he would start writing down in his little book. Now, bear in mind that V, which was the distance travelled when they hopped forwards and backwards in the geometric series, this time a slightly less straightforward calculation shows that the distance W minus V is actually minus a half W. And that tells us that the distance travelled is now 4/9 and not 2/3. Not satisfied with this challenge alone, and having told Fermat about using Fibonacci numbers, they wondered about multiplying the original geometric series as an alternating series where they hopped forwards and backwards by first of all the Fibonacci numbers, and secondly by the Fibonacci numbers and the natural numbers, and see how far they would travel. So Freddie tried hopping a distance x using those individual distances, whereas the other two tried the new approach, multiplying those each by natural numbers to see how far they would get. Now this time you can show that the distance travelled using the original geometric series multiplied by the Fibonacci series and hopping forwards and backwards gives you a distance of 0.8 from the start, whereas a slightly more detailed calculation shows you that if you multiply each of those distances by the natural numbers as well, using the Fibonacci relationship, turns out to be exactly the same as without multiplying by the Fibonacci numbers. So it's still 0.8. So we have the remarkable property that if you multiply the geometric series with alternating signs by the Fibonacci numbers and by the Fibonacci numbers and the natural numbers, the answer is exactly the same. Well, Fermat had been thinking quite a lot about this and thought of many other different possibilities. So he suggested that, starting with this geometric series and the geometric series multiplied by the natural numbers, for which these two results held, and noticing that the Fibonacci numbers multiplying the original series and the second series gave you exactly the same answer, so you travelled exactly the same distance, he wondered what would happen if you shifted in the second two series the Fibonacci's by one place. What would you end up with? Well, the first series is similar to a previous series with the alternating geometric series hopping forwards and backwards, but now multiplied by the Fibonacci numbers starting from the second one onwards, and this is the sum Z. Now, bearing in mind that without that shift the answer was 4/5, what do we get now? Well, again, a slightly less straightforward calculation shows that a half of z is 1/5. In other words, z is 2/5, and the distance now is 2/5, which means that if you shift all of the Fibonacci numbers along by 1, when you've multiplied that geometric series, which alternates in sign, then you get 1/2 of the answer. And as we recall, that answer was the same as multiplying the Fibonacci numbers and the geometric series by the natural numbers. What happens now, though, when we shift in that alternating geometric series together with the Fibonacci numbers and the natural numbers by 1? So the series at the top with the Fibonacci numbers shifted by 1, but also each multiplied by the natural numbers and still alternating in sign. Where does this get us to? Well, they all thought long and hard about this. Both Freddie and Fibonacci started hopping around, seeing what they thought the answer would be, but they didn't really seem to be getting anywhere at all. In fact, you could argue they got nowhere at all. So Fermat said, oh, well, why not rewrite the series in a slightly different form? And they thought, well, that doesn't seem to help. But he said, oh, you might as well also call it f. Now, bearing in mind what x and y were, he said, and noticing that y was the same as x, he suggested they use the following expression, which seemed rather simple, and then he just hopped off, which is precisely what I'm going to do now and see if you can find out the result. Thank you very much for listening.